Okay, guys, as we get ready to move further along in lesson 6.1, it's important for us to understand what perfect squares are, perfect cubes, perfect quartics or perfect fourths, and perfect fifths. I don't think we'll go as far as perfect sixths, but it is important for you to begin to memorize the highlighted sections of the chart on your left. In studying exponents and powers, we've already talked about what an exponent means in regards to its base. Corresponding to every power, there is a root. For example, just as there are squares or second powers, there are square roots. Just as there are cubes, third powers, there are cube roots, and so on. And 5 squared equals 25. 5 is a square root of 25. So we have our power, and we have the number 5, which is the square root of 25. And so forth with the power 5 cubed. 5 is a cube root of 125. 5 fourths, 5 is a fourth root of 625. And so on. This pattern suggests a definition of the nth root. If a to the nth equals b, with a and b real numbers, and n is a positive integer, then a is an nth root of b. Another way of saying that is a equals the nth root of b. A is the number that if you multiply it n times by itself, you will get b. This is our first time looking at a root. So let's talk about some of the characteristics of a root. The nth root of x, nth, n is your index, this symbol is called the radical, and x is what we call the radicand. It's the real number that's underneath the radical symbol. Now back to this idea about the nth root. If the nth root is odd, there is one real nth root of x, denoted in the radical form as the nth root of x. So if the nth root is odd, an example would be the cubed root of 8. Here you see the root, the index, the nth root is an odd value. So there's only one real root, that is the cube root of 8. And that's 2, because 2 times 2 times 2 equals 8. Now, if the nth root is even, and x is positive, there are two real nth roots of x. The positive root is what we call the principal root. The negative root, it's called its opposite. An example would be the fourth root of 16. Here, you see that the index is even, or the n value is even. So the principal root, the positive root, would be positive 4, because 4 times, positive 2, because 2 times 2 times 2 times 2 equals 16. The opposite of that root would be negative 2, because negative 2 times negative 2 times negative 2 times negative 2 equals 16. So there are your two possible answers, plus or minus 2, when the index is even, an even nth root. Okay, here, taking a look at an example, we notice that we can be asked about real roots in two ways. One, we could simply be looking at a sentence or a question. What are the real cube roots of 0.008, negative 1,000, and 1 over 27? This question could also be written as I've shown here in the bottom left corner, with just expressions asking you to find the cube root of the same values. Well, as we stated earlier, there's only one real cube root of each of these values, because the index is an odd integer. So, for 0.008, 0.008 equals 0.2 cubed. Thus, 0.2 is the only real cube root of 0.008. Does that make sense? Because 0.2 times 0.2 times 0.2 would give you 0.008. Looking at negative 1,000, we know that negative 10 is the only real cube root of negative 1,000. It's the only number that we can multiply by itself 3 times and get negative 1,000. And fractions are no different. 1/27 could be rewritten as 1 to the third over 3 to the third. Thus, 1/3 cubed equals 1 over 27. So we know that 1/3 is the only real cube root. Of 1 over 27. Now be careful, because this question could also be asked a different way. What if we said, what are the real fourth roots of these numbers? We would then know that there are two possible real roots to each of these values, fourth root, right? There's going to be one positive and one negative. Now, the numbers we did prior to in example A may not be as clean for the fourth root, so Let's look at this example with a number like 1. What is the fourth root of 1? Well, what number times itself 4 times will give you 1? 1 times 1 times 1 times 1. So that is 1 is one real root, real fourth root of the fourth root of 1. Another possibility would be -1 times -1 times -1 times -1. That would also give you 1. So -1 would be your negative real root to the fourth root of 1. So 2 possible real roots are plus or minus 1. Remember, we call the positive root the principal root, and we call the negative root the opposite of that root. What about two possible real fourth roots of 16 over, let's say, 81? What is a value in the numerator that could be multiplied by itself 4 times to equal 16? Because all this says is, what's the fourth root of 16 over the fourth root of 81? So we know that 2 times 2 times 2 times 2 equals 16. And that's the same thing as saying 2 to the fourth. And we know that 3 times 3 times 3 times 3 equals 81. That's the same thing as saying 3 to the fourth. So we know that the one real fourth root of 16 over 81 is 2/3. The principal root would be positive. The opposite of that would be negative 2/3. So we say plus or minus 2/3 are the 2 possible real fourth roots of 16 over 81. Now remember, we have 2 possible real fourth roots because the index is even. If you want to review any of the examples I've done so far, your book goes more in depth on page 362. One thing we need to be careful about is being able to identify that any even root, even index roots are not going to have negative radicands that can be solved. So for instance, the fourth root of -1. There's no real root because there is no real number whose fourth power is -1. So what that means is -1 times -1 times -1 does not equal -1, right? -1 times -1 is 1, times -1 is -1, times -1 is 1. So this does not work. And that will be the case anytime you have a negative radicand with an even index. So just be careful to look out for that. That's a negative radicand, this value here, and an even index will always result in the answer being none for real roots. Okay, we'll go over that a little bit more in class.